Imagine waking up and realizing that everything, buildings, stars, even space itself, is drifting apart. This isn't science fiction, it's the real behavior of our universe. For 13.8 billion years, space has been expanding ever since the Big Bang, the event that marked the birth of everything. Contrary to the explosive image the name suggests, the Big Bang wasn't an explosion in space, but an expansion of space. Time, matter, and space itself all emerged from an unimaginably hot and dense point. In the earliest fractions of a second, the universe expanded faster than light in an event called cosmic inflation, eventually cooling to allow particles, atoms, and later galaxies to form. But how do we even know the universe is expanding? The answer lies in a discovery made by Edwin Hubble in the 1920s. Light from distant galaxies appeared stretched or redshifted, suggesting they were moving away from us. The farther away a galaxy is, the faster it's receding. But this doesn't mean Earth is the center. Instead, space itself is expanding everywhere. Imagine raisins in rising dough. As the dough expands, the raisins grow farther apart. Not because they're moving, but because the dough itself is stretching. But that raises a strange question. What is the universe expanding into? The answer? Nothing. The universe isn't expanding into some pre-existing space. It's creating space as it grows. There is no outside the universe because space and time began with the Big Bang. There's no edge or border to pass. It's more like everything is inside the expansion. At first, scientists thought gravity might slow this expansion, maybe even reversing it in a big crunch. But in 1998, researchers observing distant supernovae discovered something shocking. The expansion of the universe is accelerating. This acceleration, which acts against gravity, is driven by something we now call dark energy, a mysterious force that makes up about 68% of the universe. Even more bizarrely, another 27% is dark matter, which doesn't emit light but has gravity. That means everything we see, stars, planets, people, is just 5% of what exists. So where is this expansion taking us? There are several theories. One is the Big Freeze, where galaxies move so far apart that stars burn out, the universe grows cold and dark, and no new stars form. Over trillions of years, it becomes a quiet, lifeless void. Another possibility is the Big Rip. If dark energy keeps growing stronger, it might tear galaxies, planets, and even atoms apart. Then there's the Big Crunch, where expansion reverses and the universe collapses back into a hot, dense state, potentially triggering another Big Bang. Current data points most strongly toward the Big Freeze, but we still don't fully understand dark energy or the universe's ultimate fate. What we do know is that every atom in your body was once inside a star. The iron in your blood, the oxygen in your lungs, all were born in the hearts of massive stars and scattered by supernova. In that sense, you are not just a part of the universe, you are the universe. And somehow, against all odds, beings like us emerged not only able to question our origins, but to observe distant galaxies, measure time across billions of years, and understand cosmic forces we can't even see. We exist on a pale blue dot surrounded by unimaginable vastness, but we have the tools to explore it. Telescopes, satellites, and above all, our curiosity. Every time you look at the stars, you're seeing ancient light that began its journey before humans even existed. Space itself has stretched and captured. The fact that this light reaches your eyes is a miracle of space and time. So as our universe continues to expand into the unknown, remember, we are part of that journey. If you found this incredible, be sure to like, subscribe to Deep Space, and hit the bell so you never miss a trip into the cosmos. I'm Abdo, and this is Deep Space, where curiosity meets the universe.